Hey guys, I hope you're all doing well and enjoying your summertime. So, starting this week, we are at week 3 right now. I'm gonna talk about editing and debugging the VI and creating sub VIs and talking about array and clusters. So, let's start with debugging the VI and editing it. So far, I have discussed some part of that, some sections of debugging the VIs and editing the VIs in the last week. But for today's video, we're gonna specifically focus on debugging a VI and give you the tool. I introduce you the tools that are necessary to debug your VI. You can practice that with any of the VIs that you have built to understand it better. It's useful when you build a big project and a big VI, and you need to know where you have made a mistake building your program and you want to go step by step. So basically, debugging means finding a problem in your program. You can have any language of programs, MATLAB, C language, or Java, or LabView, anything. Debugging is like going step by step and finding the problem in your programming. So it helps you to find the issue, the way that you program, maybe in your algorithm. It will help you how to find that issue and how to solve it. So in today's video, I'm going to talk about how we can do debugging in LabView, because LabView is a graphical language for making a program, and the debugging method of it is also different than other languages. So let's start opening a new VI, a new LabView page. And today we're gonna actually make a really simple problem, which is basically we're gonna make a calculator that does add, subtract, multiplication, and division. So first of all, let's go to the front panel, right click, and we have in the containers, there's a control. We have something called a tab control. I just want to show you this, which I think it's cool. It just makes your VI look nicer. So click on that and put it somewhere in your front panel. You can make it as big as you want by selecting it, like any size that you want. You can change the name here of the tabs, and so many other things that you can do. I guess you can click on it and add a page after, or before, or whatever. Like you can start adding tabs to what you want to do. So we don't need 3 tabs right now. We just need 2 tabs for this specific problem. But yeah, you can create tabs, and this is only for a user, so it doesn't do anything in the programming. What it does is just that it makes the front panel clean for the user, so the user can click on different tabs and see different things, which I thought it's cool just to show it to you. So what you wanted to do is that we want to have 2 pages. The first page we're gonna have our like numbers, our controls. Type your number. So I'm going to give a number to it, a label to it. And then the second page, because we're making a calculator, is gonna be our results. So something like that. So when you want to make a calculator, a user has to type the number that they want to add, subtract, or whatever. So those number is something that the user defines. So those are controls. So that's why we have to go into the front panel, right click on the front panel, go to numeric, and then numeric control. Choose a numeric control and put it here, and say that this is my number 1. And then do the same thing, go to numeric, numeric control and say this is your, for example, number 2. So we basically are going to get these 2 numbers and do some mathematical function on that. So I'm gonna choose these 2 and I'm gonna align them. So you can do anything that you want in here, like any way. You can see it's really easy to just follow. And I'm gonna probably bring them into the center. So far, this is what we've built in the front panel. Look how it looks in the block diagram. So whatever you created in the front panel is in the block diagram too. We don't need the tab control because tab control doesn't do any like programming. It's just a visual. So you don't need to do any programming to it. You can put it aside somewhere. But these 2 are the things that you're going to do programming with. You can either do multiplication, division, addition, or subtraction. Because there are 4 different ways that you can do these things to it, and depending on what the user type, so you have to choose a structure here. So this is how we say it. If a user type plus, that means addition, so use the addition function. If a user type subtract, that means subtraction, so use the subtract function. If a user type like a cross or multiplication, that means it's a multiplication, so use a multiplication. And if a user type divide, this sign, then that means it's a division, so use a division function. So this is like if, and if. So you need to use a structure which is called a case structure, which is an if statement. So you define a case structure. But when I define a case structure, I see I only have true and false here. And the color of my the case selector, which is my constraint, is green. So I remember from what I've taught you before that green means a boolean. It means true or false. But I don't have a true and false here. I have plus, subtract, multiply, and division. How can I change that to something that a case structure can understand? So fortunately, there is another way that you can use a case structure, and that's with a string function. So with a string control. So string is basically text. So, and if you remember from the previous videos, when we have a text, the color of the control indicator or the color of the wires are pink. They are not green. So if you go to the front panel and again right click and go to the string path and select a string control and put it here. So here a string control is where a user type add, subtract, multiply, or division. So this is where a user define what kind of function they want to apply. So you see that when I when I add this control, the string control in the front panel, it also appeared in the block diagram, but inside a case structure. You don't want it to be inside the case structure. You can select it and put it outside the case structure. This is gonna be my constraint. This is what user use to define the case structure as a case selector. So you're gonna wire this to the question mark here, although the question mark is green, but it's okay. See the color of the question mark changed to pink. The wire is well made. It's not like, if it was not correct, it would be a cross. Like for example, if I delete this and if I do this, you can see this is not a right connection between 2 controls, because you can never connect 2 controls to each other. You can always connect a control to an indicator. So if If you connect something which shouldn't be connected, the wire looks something like that, and there's like a red cross on it. So you would know. So this is one way to know that your program has not been made properly and is ill made. So you can debug it. So I'll click Control Z to delete that. So you have to connect the string control to the question mark or the case selector here. So this way you can define your case structure based on whatever a user define. So in this problem, we're going to define the add function, the subtract, addition, and multiply. So you can go here and start adding all the functions that you want. In here I have only 2, so how can I add 2 more? You have to select the case structure, right click, and say add case after or add case before. That means after the subtract there will be another case, and then I'll define it as multiply, and then I add another case after, and that's going to be the division. So I have defined 4 different functions that I want to run my calculator based on that. I have connected the strings, the case selector, and I have my calculator. So I'll go and stay in one of the pages. For now, this is like the addition page. Inside the case structure, I have to right click and go to numeric and define the add. So why do I put the addition inside the case structure? Because this function only happens if a user type add in the string. So if a user type add in the string, it will come to the add window, and we will do the addition, adding function, which means add number 1 to number 2. Why do I have number 1 and number 2 outside? Because it doesn't matter what a user type as the add, subtract, multiply, or divide, because it doesn't matter. I mean, numbers, like if I want to add number 1 to number 2, if I want to add these 2 numbers, I will always add number 1 to number 2. But I can change that to multiply or to subtract and all these things. And this number 1 and 2 are always number 1 and 2. So they have to stay outside the case structure because they are not sensitive to whatever function a user choose. So that's why the only thing that is sensitive to the function that user choose is the function itself. So that's why these 2 are outside, but the function is inside the case structure. And then you have to right click on the results and say create an indicator and type that as a result. So do we want a result inside the case structure or not? We don't want a result inside a case structure because we are not producing a lot of results. We are only producing one result. And that one result depends on what function user choose as a string. So we have to take this also outside the case structure. So see how I selected and moved it outside the case structure. Notice here that we are having like a square that is not filled, but it is white. The reason is that there are some in the other pages, this hasn't been connected to anything. So this is like white for now. I'll talk to you what it means and how we can change things. So now when a user type number 1 and number 2, depending whatever function they choose, it will go to that function page and then produce one result. And the results you can see is put here, but we're gonna put it inside a tab section just to make it look nice. So let's go back and let's go to the other windows and start doing the same thing. So we are in the subtract window. We go to right click, numeric, and subtract. and say again if you want to subtract number 1 and 2, and then the results here. And then we go to the multiply. We do the same thing, right click, go to numeric, choose multiply function, and multiply these two. And now division, like dividing, sorry. So numeric, and then divide. And you connect them all together. See, notice the last thing I connect, like it was white, but once I connect this to that, it turns like it fills. It means that we have connected all in all different windows, like in all the 4 windows, this node is connected to something. So it's not open. It doesn't necessarily mean that it has to be open, but if it's like open, if it's like white, you have to define that either connect it to something or wire it, or just say I don't care, it can be open. For example, if I add another case after and just call this case empty, just want to show you what it means. So this is an empty case. So basically we are not going to do anything to it. Let's see, we are having a broke arrow or a crushed arrow. That means that our program has problems. So this is one way of debugging your program. You come, look, you've built your program and you see this crushed arrow. So it has some list of errors. You click on it and the error list appears. There are 2 errors here that you can read. The first one, it says tunnel missing assignment to a tunnel. It's basically talking about this tunnel, this node. That's an assignment has been missed, so nothing assigned to it. So that's why it's white. The case or event structure does not have anything wired to the output tunnel in one or more cases. That means only one case. We haven't assigned anything to the output tunnel. Since only one frame of the structure is executed, every frame must assign values to all the outputs. Right-click the tunnel and select Use Default if unwired to relax this requirement. So, as I said, in all the windows, we have to assign a wire or some signals to this output node or tunnel. And in this empty case, nothing has been assigned. We can either assign some functions like this to that, or you can just click, select that node or tunnel, right click and say Use Default if unwired. And see, it's kind of like half filled now. So what it means is that just do nothing if this is unwired. Like come here, do nothing, and just use the default, the previous results, and just do nothing. So we have solved one of these problems, but we still have the crushed or broken arrow. So there is another error here which says no case for some selector values. A case structure must have a case corresponding to every possible value of the selector, which we have already did. An easy way to fill this requirement is to specify a default case, or a cases whose selector values include ranges to or for or from infinity. So whenever you use a case structure, there is a window that is called default. You have to assign a default to one of the windows of a case structure. Like here we have 1, 2, 3, 4, 5 windows, and one of these windows has to be a default. And that's what it is for the case structure. Otherwise you will have a broken arrow. So when you're having just a true and false, like normal, one of them is a default. I guess a true usually is a default. Doesn't really matter. But here, because we specifically changed it, the name of it, and typed like add, like subtract, multiply, divide, and typed empty, we kind of deleted the default out of it. So what you can do is that you can you can choose any one of these and just type a default here, something like that, and then you should be fine. Like, see, after I clicked, this arrow is okay. But here, actually, I'm gonna choose a default for another window, not for the negative sign, because for no specific reason, just because I wanna show you something else. So I'm gonna click on the case structure, and I'm gonna add a case after, and I'm gonna call this a default. And again, by clicking outside, this arrow should be fine, so you shouldn't have any more errors, and then you will have a default. So this is what I want to show you. So working with LabView, you might hear a word a lot of times, concatenated string. So what it means that it will basically get strings from like different controls and add them all together and then print you one big string. So I want to show you this. So if you right click on the block diagram and go to the string, and here on the string choose the concatenate strings. And if you put it here, you can always draw it down and add as much as you want, but for now I'm just gonna go with the 2. So basically you can type one string here as a control and add another string here as a constant, controlled, whatever, and then for the results it gets all the strings to each other and prints you like one big string. Something similar to the one that we practiced with the tank experiments. If you remember, we added strings to each other, and we can change a number, a floating point number, into a string and add it into a string, into the one big string. So something like that. So concatenated string is something that you might hear a lot during a LabView program. So I'm gonna add this concatenated string into the default. So for the default, it will always show that. And again, looking at here for the default and empty, because I have already changed this like node into like, we basically like we check it to be use default if unwired. So we kind of like remove this error. We also remove the error for the default for the case structure, but still we see a broken arrow. And that's for the concatenated strings, because we just put the function there and we haven't wired anything to it yet. So basically the error is asking what should it be reading, or what is the wires that going into the concatenated strings. So these errors and this error list and this arrow is kind of like your debugging method. So you can debug your program. Whenever you see a broken arrow, it means that you have something missed, or you have to connect two things that they shouldn't be connected with a wire or something similar. And then when you open that, it's gonna guide you through and help you find the issue and then hopefully solve it. When you open the error list, there is a show warning here that if you check it, it's gonna add a warning here for you. So this is also another like icons to warn you that something is wrong in your program. You can either have it on or off. Usually with the broken arrow, I would know, but for this case, we'll just leave it on in case, you know, there's another thing that, you know, focus you on the problem. So what I'm gonna say here for the concatenated string is so simple. I'm not gonna do anything weird. I basically wanna write one big strings and then have them in two separate sections. But later on, I'm gonna show you that, like with the other string function that they practiced before, you can add and change a number into a string and then add it to another string and print them all in one string. But here I'm just gonna type something simple. So I'm just gonna say create a constant, and I'm gonna type you need to provide a numeric function, something like that, and see that this is larger than the case structure. So once I clicked, it's gonna make it fit. So you can always move things around and edit your VI so you feel like you understand it and it looks nicer for you. But when this case structure is big, it doesn't mean that the wires are lost. The wires are underneath the case structure, they're still there. But I usually like to see the wires, like it's more satisfying for me. Like here, for the string, the function, the wires is still there. Like if you double click, you see the path of the wire. But as I said, I usually like to see it, like it really gets into this case selector. So I like to see it. So you can always move them. But as long as you don't delete them, they are still there. They might be beneath a surface, like a layer. But you can always double click on them, select them, and then move them around. So I want to show you something else. If I one click in here, I'll just click this wire. If I double click, I'm just gonna select all of it until it's going to a node. So this is also another like editing tips. So we can always select things and move them around and have them look nicer. So for the first node, I typed you need to provide a numeric function. For the second node, again, right click, say create constant, and then you can guide the user what kind of function they need to choose, something like that. And then for the results, if I right click and say create, and this time indicator, because this is something that's gonna be an output and it's gonna show a user. So something like that. Then this concatenated string, which is here, you can select that and put in the result section. And then you can make it like big as you want. So why did I put a concatenated string here for the default section? So when a user comes, they will put two numbers here and a function. So here in the case structure, they are like 1, 2, 3, like an empty and a plus, and all these different windows. So if a user comes and type a negative, like or a subtract function, and if they run it, like 1 minus 2 should be minus 1. In the result section, you see minus 1. If a user come and type add, it should be 3, right? So if you run it, here you'll see a 3. If a user come and type a multiplication, they should see a 2. Or if a user type a divide and then run it, it should be a half. But what if a user comes and type nothing? Like the user forgets to type anything, any kind of function, and they write it, and we run it. Once we run it, this is what happens. You need to provide a numeric function. This is what we are actually guiding a user. So it goes to the result, and it's kind of like an error, something like that. So I can kind of like, we can call it like an error. So like an error list, basically. And then this error list is gonna guide a user to choose some function. Otherwise, this is not gonna work, and it's gonna print 0 for you. So this is what this default window does. For the empty window, basically nothing happens. So when you run it like this, it goes to a default and then prints this concatenated string function. And the empty function doesn't do anything. It's just basically nothing happens here. And the reason that I added this empty for you at a time was that I just want to show you this node. So you don't need this empty window. You can, if you want to delete a specific window which was extra and you don't need that, you can always click and right click and say remove empty cases, something like that. And now you don't have that, you just remove that specific empty case. Yeah, something like that. Or you can say delete this case, and then one of the case that you just selected will be removed, like it was the add function case, but I want to keep that add function case, so I'll just say Control Z and bring it back. So so far I have showed you like how you can find the errors when you build a program with this like arrow and the error list. And previously we have talked about this highlight execution, which shows you where the program is running. And now I'm going to talk some debugging methods, like something like really simple and really fast. I'm just going to show you what these icons, these three icons here, they do. So there is this icon here that when you click on it, it will open another window for you. And then whenever you are running a program, and your program shouldn't run really fast, because then you don't have time to do it. But when you have time, you can click on whatever wires that you want, and this icon here is actually going to help you find the value that that specific wire is signaling through. So let's do this. Let's click on that, and now let's say run. And sorry, turn on the highlighting execution, because then you'll have time. It's going to run slower. And then click on run. And now if I click on any wires that I want, like this wire, it's going to name it like wire number 4. It should be wire number 1, but because previously I've done this before, it's like renaming it. But for you, it's going to be wire number 1. And then it's going to show you that this wire, wire number 4, is carrying number 1. Which is right, because this is the signal that is carrying number 1, which is 1 true. So let's do it again, and let's start like clicking on some, and then you can see like once this was running, wire number 5 is carrying number 2, which is 2 here, and then wire number 6 is carrying again 4, so 4 and 6 should be the same. So wire number 6 is basically carrying 1 again, and wire number 7 is carrying 3 because it's adding 1 and 2 to each other, and 8 is basically the same. I just clicked on somewhere else. So now I'm going to click on this wire and the results wire once I'm running it again. So okay, I was successful for the number 9, which is the string function here. And you can see that it's showing me that this wire is carrying the add as a string, so it's in quotation mark. So now let's do this one more time. For some reason, okay, so basically 8 is actually this wire. So I have clicked on it, but because it was underneath of a case structure, I couldn't see it. So now you can see like 4 is actually carrying 1, 5 is carrying 2, 6 is carrying 1 again because 4 and 6 are connected. 7 is actually 1 plus 2, which is 3, and then 7 and 8 are connected, so 8 is also 3, and 9 is the add as a string function. So this is really helpful when you want to debug a program that you have built, because this way you can see like step by step what numbers or what kind of string is being carried, or what kind of even boolean, a true or false, is being carried by a signal, by a wire. So for the next step, what is the number or whatever, a true or false or a string that a specific function is reading. So if it's reading a right and correct number, that means that you are good to that point, and from that point forward you have to find the issue. But if you see something weird happens using this technique, which is actually a probe watch window, you can find the issue and solve it. So you can find where the issue lay. So this is really helpful, the probe watch window. I used it a lot when I want to debug my program. I really recommend, like, when you build a program, if your program, when you run it, is going to run so fast, turn on the executing, the highlight execution. This way the program runs slower, and then you can see how the program moves, like all the nodes that they carry, all the signals. And then you can open the probe watch window and you can click on a certain wires that you are not sure what's happening. And this way you can back calculate and find the issue of your program. And whenever you are done, you can just close it, and it says that this operation will close all probes in memory. Do you wish to continue? And you just say yes, and then it deletes everything, and you'll back to whatever point you were before. So I'm gonna save this program now as a calculator, so I'll have it in the future. So I'll ask you to please open the tank example that we had done before, because I want to show you some other things, like these other icons. These icons, it's not a really good thing to show it in this program because we don't have a lot of things happening. But in the tank experiment, the tank example, we had more functions happening. So please open that, the one with the case structure. Okay. And I'm gonna make this smaller, or actually I'm gonna keep it this way. So you all remember what the tank experiment was, the tank problem was. We basically type in the volume of water that you type the initial volume of a tank, which was like 5, the total volume of the tank, the flow rate, and some like time value. And then you run the program, and then you'll have the results. So I'm just gonna stop it. And now let's say that we want to debug this program. So there's something else that is called like let's start from here. So if I say start single stepping, so it's gonna start from the very beginning and says that, okay, from the very beginning I'm gonna go with the while loop. And if I say step over while loop, it means that it's gonna pass through the while loop and gets inside. And now let's continue clicking on this more and more. Like it says, the very first thing after while loop is this wait, the stopwatch. So it says that after this is done, I'm gonna go here. And then click one more time, and it says that after I'm done with that, I'm gonna go inside this the flat sequence one. And after that, I'm gonna go to the first layer of the flat sequence. And then after I'm done, I'm gonna go to the second layer of the flat sequence, and I'm gonna run this multiplication function, and then the addition, and then the comparison, and then the subtraction, and then I'm gonna go inside the case structure. And after that, inside the case structure, I'm gonna go with these functions one by one. And then I'm gonna get out, and I'm gonna wait another 1000 seconds, and I'm gonna redo. Because if you remember, for this specific problem, the program is gonna calculate the time that is remained to stop the pump, or the volume of water that overflowed from the pump, over again until a user stopped the program, either with this stop icon and with this stop icon here. So this is what it shows. So basically this step over, it's just gonna go like one step at a time, go and show you which function is gonna happen later and later while you're running a program. It's kind of like this highlight execution, but for highlight execution, everything happens at the same time and it goes faster. That's hard for you to follow with your eye. But with this icon, you can go step by step and see what happens next. Sometimes you wire things to each other, but you don't want a specific function to happen earlier, but because of the way that you wire them, it happens earlier in the program. So this way you would know, oh, okay, this function is happening prior to the other function and I don't want that. So you will figure out the problem and you can rewire things and find the issue and your mistake. So this is helpful. There's also another one that says step over stop VI and build text. So it basically skip this one and gets out. And then you can, basically it goes back and skip out of everything and gets out. And then there's also another one says finish while loop. So wherever you are, if you click on it, it's gonna stop it. Or this is basically it's gonna stop it. So it just stops it. So if I go again and let's say I'm here, so starting again is going to show the while loop. If I click on the next one which says step over while loop, it's basically going to get out. So it's just going to step over that specific layer. But if I, so you have to, but while it's running this thing, there's like this pause icon. Let me show you that it's happening. So if you start going step by step inside and see what's happening, and you say, okay, I found my issue, I'm done, or I didn't find any issue, I'm done, I want to get out, you have to unpause this thing, and then, because for this specific problem, we have this stop icon, you have to stop this. So click here and there, and then you stop the program. So this is basically it basically shows you like step by step every function as you move, like how the program goes from one function to another function and to another function. So in today's video, we actually talked about how to build a third VI with like a calculator, and I have showed you how to use a string as a constraint for your case structure. So your case structure doesn't have to be just two windows of true and false. It can have different windows based on what you define for it. And we also talked about some debugging techniques like this broken arrow thing in the error list, the highlight execution, the probe watch, and then the single step debugging method that you can go step by step through different functions. So hopefully you can use these debugging techniques in the future whenever you build a program, and find if you have a program that is not working fine, find your problem and solve them really well and solve them actually fast and well. See you in the next video.